Have you ever looked up at the night sky and wondered how humans first made sense of those twinkling lights? Long before rockets and satellites, people told stories to explain the stars, planets, and comets. From heroes and monsters to mysterious signs in the sky, imagination filled the unknown. These early tales sparked a curiosity that would one day launch humans into space, turning wonder into real exploration. Today, we'll trace that incredible journey, from ancient stories to the rockets that reach the stars. Fact 1. The endless curiosity. Why we explore. Space. Have you ever stared up at the night sky and felt that little tug in your chest, like something out there is calling your name? That feeling, curiosity, is the very reason humans have always looked beyond our world. Long before rockets, satellites, or astronauts, we were already asking questions. What's out there? Are we alone? Can we go there? Curiosity isn't just about knowing things, it's about imagining possibilities. Imagine the first person who looked at the stars and wondered if anyone or anything lived among them. That spark is what drives every space mission, from sending tiny satellites to distant planets, to building massive telescopes that peer billions of light years away. It's what pushes engineers, scientists, and dreamers to risk so much for the thrill of discovery. And here's something interesting. Space exploration isn't just about outer space. When we reach for the stars, we learn about ourselves, how our planet works, how life survives in extreme environments, and how fragile our home really is. Some of the technologies we use in space, like water filtration systems and solar panels, come straight back to improve life on Earth. Curiosity takes us outward, but it also brings knowledge home. Every satellite, probe, or astronaut mission begins with a question and ends with countless answers we didn't even know we were looking for. And the best part, the more we discover, the more questions pop up. That endless curiosity is exactly what keeps the adventure alive, today, tomorrow, and for generations to come. Fact 2. From myths to rockets. Humanity's journey to the stars. Long before rockets and astronauts existed, humans tried to make sense of the sky with stories. Constellations weren't just dots of light, they were characters in tales, heroes, monsters, and mysterious beings that helped people explain what they saw above. People watched the sun rise and set, followed the moon's path, and feared the sudden streak of a comet. The sky was alive with meaning, a canvas for imagination and lessons. These stories were how humans first connected with the cosmos, using narrative to understand patterns, seasons, and the mysteries of night. As centuries passed, a shift began. Observation, measurement, and experimentation revealed that the stars were distant suns and the planets were distant worlds, not mystical figures. This change, from myth to science, was the foundation of humanity's journey into space. People began asking not just why, but how, seeking explanations grounded in reality. That curiosity set the stage for the era of rockets and exploration. By the late 19th and early 20th centuries, visionaries like Konstantin Tsiolkovsky, Robert Goddard, and Hermann Oberth started imagining machines that could leave Earth. They studied physics, designed engines, and sketched plans for spacecraft long before the technology existed to build them. Imagine the excitement and audacity. Humans dreaming of flying into the void above, leaving behind the planet that had been home for millennia. Those early ideas were fragile seeds, but they sparked a chain of innovation that would eventually lead to the space age. What's remarkable is how humanity's past stories still echo in modern exploration. Space missions often carry names inspired by those old tales. Missions called Apollo, Artemis, or Orion, connecting the imagination of our ancestors with the science of today. These names remind us that curiosity and creativity have always been intertwined with discovery. Even as engineers calculate trajectories and scientists analyze data, the human desire to reach for the stars remains rooted in wonder. This journey, from storytelling to space travel, shows how imagination drives innovation. We started by mapping patterns in the night sky and creating myths to explain them. Then we measured, experimented, and calculated. Finally, we built rockets, probes, and spacecraft that carry humans and machines beyond Earth. Each step reflects the same core impulse, to explore the unknown. Looking up at the night sky today, it's easy to forget how far we've come. The same stars that inspired myths now guide spacecraft, satellites, and telescopes. Humanity has moved from interpreting the sky with stories to physically reaching toward it, a journey that is far from complete. Curiosity, imagination, and the drive to explore continue to push us outward, one rocket, one mission, and one discovery at a time. Fact 3. The space race, a new frontier of rivalry and discovery. In the mid-20th century, space exploration became more than curiosity. It became a competition. The United States and the Soviet Union turned the sky into a new battlefield, racing to show technological superiority. It started with satellites. Sputnik's beep in the night shocked the world and quickly escalated to human spaceflight. There was fear, pride, and ambition all rolled together. Each launch, orbit, and milestone wasn't just a scientific achievement. It was a statement. We can do this. We are the future. The space race pushed rapid innovation. Rockets got bigger, computers got faster, and humans started leaving the planet for the very first time. And even though it was a rivalry, it brought the world incredible discoveries. We learned to send people safely into orbit, conduct experiments in microgravity, and dream bigger than ever. In a way, that tension between nations created a springboard for everything that followed, like the first moon landing and the International Space Station. Fact 4. The first steps beyond Earth. Pioneers and dreamers. Imagine the courage it took to sit in a rocket and launch into the unknown. Yuri Gagarin, the first human in space, didn't know exactly what he'd find beyond the atmosphere. Astronauts like him were more than explorers. They were test pilots for humanity, stepping into a void that no human had ever survived. These pioneers weren't just brave, they were patient. Years of training, simulations, and preparation led to seconds of weightlessness and orbit. Every tiny success became a building block for the next mission. They proved that humans could not only survive but live in space, paving the way for long-term exploration, like the space stations we have today. And while we often celebrate the famous firsts, every step beyond Earth, every orbit, every experiment, is a story of quiet determination, teamwork, and wonder. It's a reminder that exploration isn't just about technology, it's about human spirit. Fact 5. What space exploration really means. Space exploration isn't just launching rockets or landing on planets. It's a mindset, a way of asking questions that push boundaries. When we explore space, we're testing technology, expanding knowledge, and even understanding what it means to be human. It's also practical. Satellites track weather, monitor climate, and connect the world. Space exploration gives us tools and insights that shape daily life. Yet at its heart, it's about curiosity, the desire to know what's out there and how it relates to us. Think of every probe, rover, and astronaut mission as part of one enormous story. A story that started with myths, grew through science, and continues to unfold. Each mission answers some questions and raises countless more, inviting everyone to look up, wonder, and imagine the possibilities. Fact 6. The first artificial satellite. Sputnik's beep heard around the world. Imagine it's the 4th of October 1957. People are going about their day, and suddenly the sky holds a new kind of wonder. In the Soviet Union, engineers had just launched Sputnik 1, the very first artificial satellite to orbit Earth. It was a small, shiny sphere with 4 thin antennas, and it made a simple, rhythmic beep. But that beep wasn't just sound, it was history. Suddenly the world realized humans could leave the ground and stay in orbit. Governments and scientists everywhere stared at the sky in awe and, in some places, alarm. That little satellite showed that space wasn't just a dream, it was now within reach. It also sparked what would become the space race, pushing countries to explore further, faster, and bolder. Sputnik was tiny by today's standards, but its impact was enormous. It taught engineers about orbital mechanics, radio communication, and how fragile satellites could be in the harshness of space. And though it only stayed in orbit for a few months, its legacy is still felt. Every satellite you rely on today, from GPS to weather tracking, can trace its roots back to that first little beep. Fact 7. The launch of Laika, the first living creature in space. A few months after Sputnik, the Soviets did something extraordinary and heartbreaking. In November 1957, a dog named Laika became the first living creature to orbit Earth. She was small, calm and brave, launched aboard Sputnik 2. No one knew if she would survive, but the mission proved that living beings could endure the weightlessness and radiation of space. Laika's journey was short. She didn't survive, but she taught scientists invaluable lessons. Engineers learned how to design life support systems, measure physiological changes in space, and study stress in weightlessness. Her courage paved the way for humans to follow. It's a sobering reminder that exploration often comes with risk. Yet Laika's story is celebrated not just for her sacrifice, but for opening a door that led to astronauts like Yuri Gagarin. And whenever we think of the first steps into the unknown, her tiny heartbeat orbiting Earth reminds us that curiosity often comes with courage and compassion. Fact 8. Yuri Gagarin, the first human to orbit Earth. April 12, 1961, a day forever etched in history. Yuri Gagarin, a pilot from the Soviet Union, became the first human to orbit our planet. Imagine the mixture of fear and excitement as he sat in the Vostok 1 capsule, knowing he was leaving the Earth no human had ever circled before. During his orbit, he experienced weightlessness, saw the curvature of Earth, and reported back with simple words, "I see Earth. It is beautiful." That single flight wasn't just a technical triumph, it captured the imagination of millions worldwide. People looked up at the sky and realized humans could truly venture beyond their home. Gagarin's journey also symbolized what I mentioned in the earlier fact about pioneers. The bravery of stepping into the unknown. Every orbit, every test, every heartbeat in space built a foundation for long-term human exploration, including the International Space Station and the missions to come. Fact 9. The Mercury missions, America's first astronauts. After the Soviets took the lead with Gagarin, the United States quickly launched its own program, Mercury. The goal was simple but daring: put an American in orbit and bring them back safely. Astronauts like John Glenn and Alan Shepard trained endlessly, learning to handle tiny capsules, high G-forces, and the unknown of space. The Mercury missions were short, sometimes just a few hours, but they proved humans could survive in orbit and return home. These flights weren't just about heroics, they were about science, testing life support systems, and figuring out how to control a spacecraft with a person inside. It's fascinating to see how Mercury connected directly to future programs. The lessons learned, how humans eat, sleep, and move in microgravity, are still relevant for space stations today. Mercury wasn't flashy, but it was crucial. Without it, astronauts wouldn't have been ready for Gemini, Apollo, or the moon landings. Fact 10. The Gemini program, testing the future of space travel. By the mid-60s, NASA had a bigger challenge: prepare humans for the moon. Enter Gemini. This program tested everything that Mercury didn't: longer missions, spacewalks, docking maneuvers, and rendezvous techniques. Astronauts spent days in orbit, learning how to work together in the tight confines of a spacecraft. Gemini was like a rehearsal for Apollo. Without its experiments, we wouldn't know how to maneuver in space, how to fix problems mid-flight, or how humans could endure longer journeys. Astronauts like Ed White and Jim Lovell became experts in zero gravity, showing that humans could adapt, survive, and even thrive beyond Earth. This program also reminds us of something I mentioned before. Every mission builds on the last. Mercury taught us humans could survive in space, Gagarin proved it first, and Gemini showed us we could do the work needed for the moon. It was a perfect bridge between early exploration and the giant leaps to come. Fact 11. The Apollo program, a giant leap for mankind. By the mid-1960s, the world was caught in the excitement and pressure of the space race. The United States launched the Apollo program, a series of ambitious missions with one ultimate goal: put a human on the moon. But Apollo wasn't just about getting there. It was about mastering every detail of space travel. Rockets had to be enormous, spacecraft had to be precise, and astronauts needed training beyond anything imaginable. What's incredible is how much Apollo represented teamwork. Engineers, scientists, and astronauts worked together to solve problems no one had faced before. From designing the Saturn V rocket, the most powerful ever built, to planning orbital mechanics that would get a spacecraft from Earth to the Moon, every tiny decision mattered. Apollo became more than a technical challenge. It was a symbol. It showed that humanity could achieve the impossible with courage, ingenuity, and collaboration. It's the program that turned dreams of the Moon into reality, and it set the stage for everything we've done in space exploration since. Fact 12. The Moon Landing. When Humans Touched Another World, July 20th, 1969. Neil Armstrong stepped onto the lunar surface and said words that instantly became iconic. That's one small step for man, one giant leap for mankind. But it wasn't just Armstrong. It was Buzz Aldrin, Michael Collins, and the thousands of people on the ground who made that moment possible. Imagine looking at the Moon through a telescope your whole life, and then realizing humans were actually there, leaving footprints on the dusty surface. The landing wasn't just science. It was a story of courage, precision, and ambition. The astronauts conducted experiments, took photographs, and collected samples, proving that humans could live and work on another world, even if only briefly. The moon landing captured hearts worldwide. People felt a connection to something larger than themselves, a reminder that curiosity can take us to unimaginable heights. And it wasn't the end. It was just another beginning in our journey beyond Earth. Fact 13. The Forgotten Apollo Missions. Beyond Apollo 11. Everyone remembers Apollo 11. But did you know there were a total of 6 successful moon landings? Apollo 12, 14, 15, 16 and 17 all followed, each exploring different regions of the lunar surface and carrying out experiments that Apollo 11 couldn't. These missions tested longer stays, more complex tasks, and even lunar rovers. Astronauts like Alan Bean and John Young spent days walking across craters, gathering rocks, and conducting science experiments. Each mission taught us more about the moon's surface, its formation, and its potential for future exploration. They may not have captured headlines like Apollo 11, but these forgotten missions built a deep understanding of our nearest neighbour and set the foundation for the possibility of returning someday. Fact 14. The Moon Rocks. What they taught us. One of the most remarkable legacies of the Apollo missions isn't the photos of astronauts bouncing across the lunar surface or the flags planted in the dust. It's the moon rocks they brought back. Carefully collected by astronauts during their expeditions, these samples opened a window into the moon's mysterious past, revealing details that telescopes and satellites could never show. The rocks themselves are diverse and fascinating. Many are ancient volcanic formations, some dating back more than 4 billion years, older than almost anything on Earth. Some are solidified lava flows, while others are breccias, which are rocks formed from fragments of older materials fused together during meteor impacts. Every sample carries a story, not just about the moon, but about the history of the entire solar system. By studying these rocks, scientists uncovered crucial information about the moon's formation and evolution. Evidence supports the widely accepted theory that the moon was created after a massive collision between Earth and a Mars-sized object early in the solar system's history. The moon rocks also revealed a history of meteorite impacts, helping researchers understand how violent collisions shaped planetary bodies billions of years ago. Even the moon's surface layers preserve a record of the sun's activity and the early environment of our solar system. The moon rocks aren't just scientific tools. They are a physical connection to another world. Holding a piece of the moon in your hand is a reminder that humans have actually left Earth, travelled through space, and touched another celestial body. They transformed abstract ideas about space into tangible evidence that exploration is possible. Beyond their scientific significance, the rocks have inspired curiosity, imagination, and wonder. Museums around the world display them as reminders of what humanity can achieve. Every grain of lunar soil, every shard of basalt tells a story of daring missions, careful collection, and decades of study back on Earth. Scientists continue to examine these samples using ever more sophisticated technology, discovering new details that even the Apollo astronauts couldn't have imagined. Moon rocks also paved the way for understanding other planets and moons. By comparing them with meteorites and Earth rocks, scientists can identify common processes across the solar system, such as volcanic activity, impacts, and surface evolution. These insights influence not only planetary science, but also ideas for future missions, including returning humans to the Moon or sending astronauts to Mars. In short, moon rocks are more than just space souvenirs. They are pieces of history, geological records of a neighbouring world, and tangible proof of human curiosity and achievement. They teach us where the Moon came from, how it has changed over billions of years, and how exploring beyond our planet can expand our understanding of the universe. Every sample is a silent teacher, connecting Earth to the Moon and reminding us that the sky is not the limit, it's just the beginning. Fact 15. Why we haven't returned to the Moon. It's been decades since humans walked on the Moon, and many wonder why we haven't gone back. The answer isn't lack of interest, it's mostly about resources, risk and priorities. Lunar missions are incredibly expensive, and governments have had to balance space exploration with other urgent needs on Earth. Technology is also a factor. The spacecraft used for Apollo are no longer in service, and building new systems takes time and money. But there's renewed interest today. Programs like Artemis aim to return humans to the Moon in the coming years, this time with plans for sustainable bases and longer exploration. So while we haven't been back in a long time, the Moon is still calling, and when we do return, it won't just be a visit, it will be the next chapter in humanity's journey into space. Fact 16. The birth of NASA. It's 1958, and the world is changing fast. The Soviets had just launched Sputnik, and suddenly, space wasn't a dream, it was a competition. In response, the United States created NASA, the National Aeronautics and Space Administration, to coordinate space exploration and make sure America wasn't left behind. NASA wasn't just a government agency, it was a hub of vision and innovation. Scientists, engineers and astronauts were brought together under one roof, all working toward the common goal of exploring the unknown. From designing rockets to planning missions to the Moon, NASA became the central force turning human imagination into real space missions. What's remarkable is how quickly they acted. Within a few years, NASA was running Mercury, Gemini and Apollo programs, training astronauts and launching satellites. The birth of NASA marked the start of organized, large-scale space exploration for the United States, and it became the model for modern space agencies worldwide. Fact 17. The Soviet space program, triumphs and secrets. While NASA was forming, the Soviet space program was quietly achieving historic milestones. They launched the first satellite, sent the first living creatures into orbit, and made Yuri Gagarin the first human to circle Earth. The program was shrouded in secrecy, so the world often learned about these triumphs after the fact, which only added to their mystique. Behind the headlines, Soviet scientists and engineers were solving problems that no one else had faced: how to survive in zero gravity, how to control spacecraft, and how to push technology to its limits. Their achievements created competition that fueled innovation worldwide, and their daring missions demonstrated what courage, resourcefulness, and ambition could accomplish. Even today, the Soviet space program's successes are studied and admired, showing that exploration isn't about nationality, it's about the drive to reach further than anyone has gone before. Fact 18. How rocket science works. The basics of liftoff. Rocket science sounds complicated, but at its core, it's really about one thing: force and motion. To leave Earth, a rocket has to overcome gravity by generating enough thrust to push it upward. Fuel burns inside engines, creating hot gases that shoot downward, which in turn propels the rocket skyward. Simple physics, extraordinary results. Designing rockets isn't just about power. Engineers have to balance weight, fuel, stability, and aerodynamics. Even small miscalculations can mean failure. That's why early missions were so risky, and why programs like Mercury and Gemini focus so heavily on testing every system before sending humans into orbit. Understanding the basics of rocket science helps you appreciate every launch you see today. Each rocket, whether carrying satellites, astronauts, or supplies to the ISS, is a precise dance of physics and engineering, a tangible example of human ingenuity meeting the laws of nature. Fact 19. The Saturn V, the most powerful rocket ever built. If rockets were giants, Saturn V would be the king. This massive launch vehicle powered the Apollo missions to the Moon, carrying astronauts' modules and equipment more than 100 miles above Earth. It stood taller than a 20-story building and could lift over 100 tons of payload into orbit. Watching a Saturn V launch was like witnessing pure energy come to life. Its engines roared, flames stretched hundreds of feet, and the rocket slowly, inexorably lifted off the ground, defying gravity. The precision required to send humans safely to the moon and back was staggering. Every stage, every fuel tank, every calculation mattered. Saturn V wasn't just a machine, it was a symbol of ambition, showing the world that humans could build something extraordinary to reach beyond our planet. And its legacy lives on in the rockets of today, inspiring engineers to keep pushing boundaries. Fact 20. The Space Shuttle era. Reusable wings in orbit. After Apollo, NASA wanted a new kind of spacecraft, one that could fly like a plane and return to Earth for reuse. Enter the Space Shuttle, a revolutionary idea that combined rocket power with airplane-like versatility. Shuttles could carry astronauts, satellites, and even components for space stations into orbit, then glide back safely to land. The shuttle era taught humanity new ways to operate in space. Astronauts could repair satellites, conduct experiments in microgravity, and even assemble the International Space Station piece by piece. It wasn't perfect. Accidents reminded everyone of the risks, but it dramatically expanded what humans could do in low Earth orbit. The Space Shuttle era bridged the gap between the early days of exploration and modern missions. It showed that space wasn't just a place to visit briefly, it could be a working, living environment where humans could perform complex tasks, learn and grow. Fact 21. Living in zero gravity. Everyday life in orbit. Imagine floating around your room all day, not touching the floor, not sinking into a chair. That's what life is like for astronauts living in zero gravity aboard the International Space Station. At first, it sounds like a dream. No heavy lifting, no commuting, but it comes with surprising challenges. Every movement needs to be deliberate. Push too hard and you could float across the cabin like a human pinball. Tools, food, and even water behave differently. Simple things like drinking or writing require adaptations. Astronauts have to anchor themselves, using straps or handrails to stay in place while working. Zero gravity also changes your body. Muscles don't need to support weight, and bones lose density, which is why astronauts exercise 2 hours a day to stay healthy. Even blood and fluids shift upward, making faces puffier and voices slightly higher. Living in orbit is a constant learning process, and it teaches resilience, patience, and creative problem-solving, all skills that astronauts rely on every day. Fact 22. Eating in space. From tubes to tortillas, eating in space is far from the familiar kitchen experience. Early astronauts ate mostly tubes of paste, little squeezable pouches that were nutritious but not very tasty. Imagine trying to enjoy a meal while floating upside down. Over time, space food evolved, and astronauts now enjoy freeze-dried meals, vacuum-sealed snacks, and even tortillas instead of bread, which crumbs can float into delicate equipment. Meals are more than survival. They're moments of comfort and routine. Astronauts rehydrate food with water, add sauces, and carefully manage packaging to avoid floating debris. Eating together also fosters camaraderie and a sense of normalcy, which is vital when living far from Earth for months at a time. From simple tubes to carefully planned menus, eating in space reflects both the ingenuity of space agencies and the human desire to maintain small comforts, even millions of miles above the planet. Fact 23. Spacesuits. Personal spacecraft for the body. Think of a spacesuit as a personal spacecraft. It protects astronauts from extreme temperatures, micrometeoroids, and the vacuum of space, while providing oxygen, temperature control, and communication systems. Every layer is designed for survival, mobility, and comfort in conditions humans weren't built for. Putting on a suit is a complex process, often taking up to an hour, but it's essential. In the vacuum of space, even a small tear could be fatal. Spacewalks, or extravehicular activities, are where these suits shine. They allow humans to repair satellites, conduct experiments, and explore areas outside the spacecraft safely. Spacesuits are more than gear. They're lifelines. They remind us how fragile humans are and how much we rely on engineering to extend our capabilities beyond Earth. Fact 24. how astronauts sleep, shower, and stay. Healthy living in space isn't just about work, it's about surviving daily life. Sleep, for example, is tricky in zero gravity. Astronauts use sleeping bags strapped to walls or ceilings to avoid floating around, and they often experience altered circadian rhythms because there's no natural day-night cycle in orbit. Showering isn't like at home either. Water doesn't flow, it floats as droplets. Astronauts use rinseless wipes and no-rinse shampoo to stay clean. Exercise is crucial, with treadmills, resistance bands, and stationary bikes used daily to keep muscles and bones strong. Nutrition and hydration are carefully monitored, and doctors on Earth track health data constantly. Even simple routines become experiments in adaptation, showing just how flexible the human body can be with the right support. Fact 25. The psychological challenges of space life in orbit isn't just physically demanding, it's mentally challenging. Astronauts face isolation, confinement, and separation from family for months. Even small stresses, like delayed communication or minor equipment problems, can feel magnified. To cope, astronauts follow strict schedules, maintain communication with loved ones, and rely on team support. Hobbies, exercise, and creative activities help manage stress. Psychological resilience becomes as important as technical skill. If the mind falters, even simple tasks become dangerous. Understanding these challenges has shaped modern space missions, teaching us how humans can thrive in extreme environments and preparing us for even longer journeys, like trips to Mars or beyond. Fact 26. Building a home above the Earth. Imagine living hundreds of kilometers above Earth, suspended in the blackness of space. That's what the International Space Station ISS represents, humanity's first true home in orbit. But building it was no simple feat. It required years of planning, hundreds of engineers, thousands of components, and dozens of launches. Every part had to be designed to function in zero gravity, withstand radiation, and survive the harsh environment of space. Think of it as assembling a giant three-dimensional puzzle, where every piece must fit perfectly, or the whole structure could be at risk. Construction combined human skill and robotic precision. Astronauts floated in space while robotic arms carefully connected modules, laboratories, living quarters, and solar panels. Every screw and connector mattered. One tiny misalignment could cause serious consequences. The scale of the project was enormous. The station spans the size of a football field and weighs nearly 500,000 kilograms. It orbits Earth at roughly 28,000 kilometers per hour, completing a trip around the planet every 90 minutes. The ISS isn't just a collection of modules. It's a home, a laboratory, and a symbol of what humans can accomplish together. Scientists conduct experiments in microgravity, studying everything from human biology to materials science. Engineers test new technologies that may one day support missions to the Moon, Mars, and beyond. Living there shows how adaptable humans can be when facing challenges that push the boundaries of engineering, collaboration, and endurance. More than a structure, the ISS represents human ambition. It's proof that space exploration isn't just about rockets or astronauts. It's about building sustainable habitats where people can live and work far from Earth. Every experiment, repair, and floating meal highlights the incredible coordination required to maintain life above our planet. The station demonstrates that teamwork and ingenuity can overcome extreme challenges. It's a bridge between Earth and the cosmos, teaching lessons about living in confined spaces, managing resources, and sustaining life in hostile environments. In many ways, it's a rehearsal for the future, where humans may call other planets home. The ISS shows that reaching for the stars isn't just a dream. It's a carefully planned, painstakingly executed achievement of human creativity and determination. Fact 27. How astronauts get to the ISS. Reaching the ISS is an adventure that begins long before a spacecraft leaves the ground. Astronauts train for months, or even years, learning the technical details of the spacecraft, emergency procedures, and the effects of microgravity. They climb aboard vehicles like SpaceX's Crew Dragon or Russia's Soyuz, which will carry them hundreds of kilometers above Earth into orbit. The launch itself is intense. Rockets roar through the atmosphere, pushing astronauts towards speeds of 28,000 kilometers per hour. Every second of the ascent is critical, as the spacecraft must reach the correct orbit to rendezvous with the station. Even minor miscalculations could require adjustments or aborts. The combination of human skill, computer guidance, and precise engineering ensures the journey is safe and efficient. Docking with the ISS is one of the most delicate operations. The spacecraft must approach slowly, align perfectly, and connect without jolting the station. Mission control guides the process, but the astronauts themselves execute key maneuvers using training and intuition. Once the hatches connect, astronauts float through the passage and begin life aboard the station, a new environment where every movement feels different and every task requires planning. The journey to the ISS is a mix of cutting-edge technology and human courage. Each mission demonstrates not only engineering excellence, but also the ability of people to adapt to extraordinary conditions. Every trip is both a technical achievement and a personal triumph, highlighting how far humanity has come in exploring space and sustaining life beyond our home planet. Fact 28. Life aboard the station. A day in orbit. A day on the ISS is unlike anything on Earth. Astronauts wake up in zero gravity, where the concept of up and down is irrelevant. They exercise to counteract muscle and bone loss, conduct scientific experiments, eat meals designed for space, and communicate with mission control. Moving between modules feels like swimming through air, and even simple tasks require careful planning to prevent floating tools or food from drifting away. Time aboard the ISS is highly structured. Experiments must be executed precisely, maintenance tasks are ongoing, and physical fitness is mandatory. Despite the strict schedule, astronauts find moments of joy, watching the sunrise over Earth, listening to music, sharing stories, or floating freely in the station's corridors. Life in orbit blends work, science, and camaraderie in ways impossible on Earth. The station is not only a workplace, but also a laboratory, where microgravity allows scientists to observe phenomena that are impossible to replicate on the planet. Astronauts become both researchers and participants in experiments, contributing to discoveries that improve knowledge in biology, physics, and material science. Life aboard the ISS is a balance of discipline, curiosity, and adaptation. It teaches lessons about cooperation, problem-solving, and the resilience of the human body and mind in unusual conditions. Every day spent in orbit is a reminder of how extraordinary human life can be when we venture beyond our familiar world. Fact 29. International cooperation in space. The ISS is a remarkable example of global teamwork. Scientists, engineers, and astronauts from the United States, Russia, Europe, Japan, and Canada work together daily to maintain and operate the station. Countries share technology, expertise, and funding, creating an environment where collaboration outweighs competition. This cooperation extends beyond logistics. It's symbolic of what humanity can achieve when united by curiosity and ambition. Even amid geopolitical tensions on Earth, the ISS proves that nations can join forces in the pursuit of knowledge and exploration. The station is a floating testament to teamwork, demonstrating that complex scientific and engineering challenges are best solved collectively. From designing modules to executing experiments and planning missions, the ISS relies on constant coordination and trust. Every crewmate and every supporting team on the ground contributes to the station's success. It is a living example that space exploration thrives on unity and shared goals, making the ISS a beacon of human achievement and cooperation. Fact 30. The experiments that changed science. One of the ISS's greatest contributions is its role as a laboratory in space. Microgravity allows scientists to study phenomena that behave differently than on Earth. Plants grow in unusual ways, fluids form strange shapes, and materials solidify in ways impossible on the planet's surface. These experiments extend from biology to physics and materials science. The research isn't purely theoretical. Insights from the station lead to real-world applications, improvements in medicine, water purification, drug development, and manufacturing technologies. Astronauts not only participate in these experiments, but also help refine procedures that might one day support life on other planets. The ISS serves as a bridge between exploration and practical innovation. It proves that reaching for the stars benefits life back home, turning curiosity into tangible progress. Every experiment expands our knowledge, not only of space but also of life on Earth, making the station a cornerstone of scientific discovery and human ingenuity. Fact 31. The first space probes, silent explorers. Long before humans could leave Earth, we sent out space probes, robotic explorers capable of surviving the harsh, airless void where people could not. These silent pioneers ventured to distant planets, moons, and even the edges of our solar system, returning data that transformed our understanding of the cosmos. What makes probes extraordinary is their ability to do the dangerous work for us. They orbit planets, photograph surfaces, measure atmospheres, and even sample materials, all without a human on board. Early missions like Mariner, Pioneer, and Venera gave us first-hand knowledge of Mars, Venus, and Jupiter in ways no telescope on Earth could match. They revealed cratered landscapes, volcanic activity, atmospheric compositions, and magnetic fields, details that expanded our knowledge of planetary science. Probes aren't flashy, but they are essential. They teach us about worlds too distant or inhospitable for humans, preparing the way for future astronauts. They also embody human ingenuity, clever engineering, precise navigation, and relentless curiosity wrapped into machines small enough to launch on a rocket but powerful enough to explore the unknown. The work of these silent explorers reminds us that space exploration doesn't always need humans in person. Sometimes, it just needs curiosity, precision, and a willingness to send our mechanical representatives into the unknown. Probes are the unsung heroes of space, quietly expanding the horizons of human knowledge. Fact 32. Voyager 1 and 2, Messengers Beyond the Solar System. In 1977, NASA launched Voyager 1 and 2, two spacecraft destined to go farther than any human-made object had ever travelled. Their initial mission was to study the outer planets, but their journey did not stop there. Today, Voyager 1 is in interstellar space, carrying information from Earth to a place no human has ever reached. Voyager didn't just carry cameras and instruments, it carried the Golden Record, a time capsule of Earth's music, images and greetings intended to communicate with any intelligent life that might encounter it. Meanwhile, the probe's scientific instruments returned incredible data. Breathtaking images of Jupiter's swirling storms, Saturn's rings, Uranus's subtle haze, and Neptune's deep blue atmosphere. Voyager shows what happens when science and imagination collide. Tiny spacecraft launched decades ago continue to carry humanity's curiosity across the stars. They teach us not only about planets and moons, but also about the possibilities of reaching beyond what we thought possible. Even now, decades later, these robotic messengers keep pushing the boundaries of exploration, proving that sometimes machines can carry our dreams farther than we ever imagined. Fact 33. The Mars rovers, Spirit, Opportunity, Curiosity, and Perseverance. Mars exploration started with robotic rovers, small but incredibly capable machines designed to navigate and study the red planet. Spirit and Opportunity were first, teaching us about Mars' past, including evidence of ancient water and clues about its geological history. Their work laid the foundation for understanding whether life could have existed there. Curiosity then brought more advanced instruments, analysing rocks and soil for signs of organic molecules and past habitability. Now, Perseverance is collecting samples intended to be returned to Earth, providing a treasure trove of information about the planet's past and its potential for human exploration. These rovers are more than machines. They are our eyes, hands, and companions on another world. Each wheel turn, each sample analysed, each photo sent back adds pieces to a puzzle, millions of kilometres away. Mars rovers embody patience, ingenuity, and the relentless human desire to explore. They show that even a small machine can make a massive impact on our understanding of the universe. Fact 34. Cassini. The mission that revealed Saturn's secrets launched in 1997. Cassini spent over 13 years orbiting Saturn, studying the planet, its rings, and its moons. The mission revealed astonishing details: geysers erupting on Enceladus, massive storms on Saturn, and intricate structures within the rings that had never been seen before. Cassini taught us that moons far from the Sun could have oceans and active geology, offering hints about where life might exist beyond Earth. Its long-term observations provided insight into planetary formation, gravity, and the evolution of complex planetary systems. Patience was key to Cassini's success. Slowly and meticulously, it unraveled the beauty and complexity of one of the solar system's most majestic planets, leaving a legacy of discovery and inspiration for future missions. Fact 35. New Horizons. Reaching Pluto and beyond. When New Horizons launched, Pluto was considered a distant icy dot at the edge of our solar system. By 2018, the spacecraft gave humanity its first close-up view of the dwarf planet, revealing mountains, plains, and even possible glaciers. Its images completely transformed our understanding of Pluto. But New Horizons didn't stop there. It is now exploring the Kuiper Belt, sending back data about small icy worlds at the solar system's outer frontier. The mission proves that no destination is too remote if we have the right technology and determination. New Horizons is a celebration of human curiosity, precision, and daring. It reminds us that even the smallest, most distant worlds can surprise us, and that exploration is a journey that never truly ends. Every discovery, from Pluto to the Kuiper Belt, expands our vision of the cosmos and the possibilities for the future. Fact 36. Mercury. The burned and frozen world. Mercury is a planet of extremes, a place where temperatures swing dramatically in a single day. Being the closest planet to the Sun, its surface bakes under scorching heat during the day, reaching hundreds of degrees Celsius. Yet when night falls, temperatures plummet so drastically that the same terrain freezes, because Mercury has almost no atmosphere to trap heat. Imagine standing on a landscape where the ground scorches your feet in the morning and threatens frostbite by night. Despite being the smallest planet in the solar system, Mercury holds some of the most striking geological features. Its surface is heavily cratered, a record of billions of years of cosmic collisions. These craters make it look like a battlefield frozen in time, each scar telling a story of impacts that shaped the planet long ago. There are also enormous cliffs, some taller than mountains on Earth, formed as Mercury's iron core cooled and contracted over eons. Mercury also surprises scientists with its magnetic field. Unlike most small planets, it has a detectable magnetic field, hinting at complex internal processes. Exploring Mercury helps researchers understand not just the planet itself, but also the mechanics of planetary formation and the influence of proximity to a star. The harsh environment makes it a natural laboratory for testing how planets endure extreme conditions. Studying Mercury's surface and orbit provides insight into how planets interact with the Sun, how crusts crack and contract, and how magnetic fields evolve. Every crater, cliff, and ridge adds to our understanding of the solar system's early days. Even though it's inhospitable to life as we know it, Mercury's extremes serve as a critical puzzle piece in understanding the diversity of worlds that orbit our Sun. Mercury teaches us that even the smallest planets can hold big mysteries. From its blazing days to freezing nights, from its jagged craters to towering cliffs, this tiny world challenges our imagination and expands our knowledge. Exploring Mercury is a reminder that the solar system is a place of contrasts, extremes, and endless surprises. Fact 37. Venus. The planet of fire and acid. Venus is a planet that seems almost alive, but it's far from welcoming. Its thick, toxic clouds of sulfuric acid and surface temperatures hot enough to melt lead make it one of the harshest environments in the solar system. A runaway greenhouse effect traps heat in its atmosphere, making it even hotter than Mercury, despite being further from the Sun. Radar mapping has revealed a surface filled with dramatic landscapes, massive mountains, vast plains, and volcanoes that may still be active. Winds swirl at incredible speeds, and pressure on the surface is crushing, hundreds of times stronger than Earth's. These extreme conditions challenge engineers and scientists designing probes that can survive even for a few hours on Venus. Despite its deadly environment, Venus teaches us valuable lessons about planetary climates. Studying its atmosphere helps scientists understand greenhouse effects, climate change, and how a planet's environment can evolve over time. Venus may be extreme, but it provides insights into resilience, both for robotic explorers and for understanding how planets develop under intense pressures and heat. Every mission to Venus, from orbiters to landers, expands our knowledge about atmospheres, volcanic activity, and planetary weather systems. The planet may be inhospitable, but it's an invaluable classroom for understanding planetary science and the forces that can shape worlds. Venus reminds us that exploring space isn't just about visiting pleasant places, it's about learning from the extremes. Fact 38. Mars. Our next great destination. Mars has fascinated humans for centuries. Its red surface, visible even with the naked eye, conceals ancient riverbeds, massive volcanoes, and the tallest mountain in the solar system, Olympus Mons, cold, dry, and dusty. It's a harsh but intriguing world, teasing scientists and explorers alike with the possibility that humans could one day set foot there. Robotic explorers like Spirit, Opportunity, Curiosity, and Perseverance have roamed the Martian surface studying rocks, soil, and atmospheric conditions. They've uncovered signs of ancient water, complex geology, and even potential chemical markers of past microbial life. Each discovery adds to the tantalizing possibility that Mars may have once been habitable, or might be suitable for human settlements in the future. Mars represents a frontier not only for science, but for human ambition. Scientists are researching technologies for growing food, generating water, and creating habitable structures. Private companies and space agencies are developing plans to send humans there in the coming decades. Living on Mars would require adaptation to lower gravity, thin atmosphere, and extreme cold, but it could also mark the beginning of humans becoming a multiplanetary species. Studying Mars gives insight into climate change, planetary formation, and the evolution of Earth-like planets. Its mysteries, from dry riverbeds to dust storms spanning entire continents, keep inspiring scientists and dreamers alike. Mars is a destination that challenges our ingenuity while expanding our understanding of what it takes to survive beyond Earth. Fact 39. Jupiter, the giant of storms. Jupiter is the largest planet in our solar system, a colossal world whose mass exceeds that of all other planets combined. Its atmosphere is a turbulent sea of clouds, with storms raging across its surface, including the famous Great Red Spot, a storm that has persisted for centuries. Jupiter is a gas giant composed mainly of hydrogen and helium, with no solid surface to walk on. Its immense gravity influences the orbits of other planets, comets, and asteroids, acting as a protector for the inner solar system. Jupiter's strong magnetic field and radiation belts pose challenges for exploration, but also provide fascinating scientific data. The planet's moons are equally intriguing. Europa's icy crust conceals an ocean that may harbour conditions suitable for life. Ganymede, Callisto, and Io each display unique geological activity, from volcanic eruptions to icy tectonics. Studying Jupiter and its moons gives scientists insight into gas giants, planetary atmospheres, and the potential for life beyond Earth. Jupiter's scale and complexity are humbling. Observing its storms, gravity, and moons reminds us how diverse and powerful worlds can be, and how each planet contributes to the larger story of the solar system's formation and evolution. Fact 40. Saturn, the Lord of the Rings. Saturn is instantly recognizable for its spectacular rings, composed of ice, rock, and dust, forming a shimmering halo that captivates astronomers and casual stargazers alike. These rings are more than beautiful. They may hold clues to the early solar system, revealing how planets and moons form. Saturn has dozens of moons, each unique. Titan, the largest, has lakes of liquid methane and a dense atmosphere, while Enceladus spews water ice into space from underground oceans. These moons hint at the possibility that even distant, cold worlds might host environments where life could exist. Studying Saturn and its system helps scientists understand planetary formation, atmospheres, and the dynamics of ring systems. Missions like Cassini provided unprecedented insights, capturing close-up images of rings, moons, and storms. Saturn combines beauty, mystery, and science, offering a glimpse into the complexity and diversity of planetary systems. The planet is a reminder that space is full of wonder, and that even in the vastness of the solar system, there are worlds waiting to teach us new lessons about physics, chemistry, and the potential for life beyond our planet. Fact 41. Uranus, the sideways planet. Uranus is a planet that seems to break the rules of the solar system. Unlike most planets, it spins almost on its side, with its axis nearly parallel to its orbit. Imagine a spinning top tipped over. That's how Uranus rolls around the Sun. This unusual tilt gives the planet extreme seasons that last more than 20 years each, with one pole facing the Sun for decades, while the other is plunged into darkness. Uranus is an ice giant, composed mainly of water, ammonia, and methane ices. Its pale blue-green colour comes from methane gas in the atmosphere, which absorbs red light and reflects blue. The planet has faint rings and dozens of moons, each with its own unique characteristics, orbiting a world that seems almost alien compared to the more familiar planets. Scientists still aren't entirely sure how Uranus ended up on its side. Some theories suggest a massive collision with another planet or protoplanet early in its history, tilting it over. Studying Uranus helps researchers understand planetary formation, ice giant dynamics, and extreme climates, showing that planets can behave in ways that are both bizarre and fascinating. Despite being far from the Sun, Uranus teaches a simple lesson. The solar system is full of surprises, and not every planet follows the rules we expect. It's a reminder that even distant cold worlds can be beautiful, strange, and scientifically valuable. Fact 42. Neptune, the windy blue world. Neptune is the farthest planet from the Sun, and it's a place where storms rage with astonishing speed. Winds can reach over 2,000 kilometers per hour, making it one of the windiest environments in the solar system. Its deep blue color, caused by methane gas, is similar to Uranus, but Neptune's atmosphere is far more active, with swirling clouds and ever-changing storm systems. One of the most famous features is the Great Dark Spot, a storm comparable in size to Earth that constantly shifts and evolves. Neptune also has icy moons, including Triton, which orbits backward, a clue that it was captured from the distant Kuiper Belt. Observing Neptune helps scientists understand extreme weather, atmospheric dynamics, and how energy behaves on worlds far from the Sun. Neptune reminds us that even the cold, remote reaches of the solar system are full of motion, energy, and surprises. It's a distant world, but one that still has a story to tell about the forces shaping planets and the mysteries waiting to be explored. Fact 43. Pluto, the debate that changed its fate. Pluto once held the title of the 9th planet, quietly orbiting at the edge of the solar system. But in 2006, the International Astronomical Union reclassified it as a dwarf planet, sparking a worldwide debate. What exactly makes a planet a planet? Why was Pluto demoted while other celestial bodies retained their status? Despite the controversy, Pluto is far from ordinary. NASA's New Horizons mission gave humanity our first close-up look at this distant world, revealing mountains, icy plains, and signs of geological activity. These discoveries proved that Pluto isn't just a frozen rock. It's a dynamic world with its own mysteries, reshaping our understanding of the outer solar system. Pluto challenges our definitions and reminds us that science evolves with discovery. Labels may change, but curiosity and exploration continue. Even if it's no longer officially a planet, Pluto still inspires wonder about the solar system's outer edges. Its icy landscapes, dramatic cliffs, and possible glaciers are a testament to the surprising diversity of worlds waiting to be studied. Fact 44. The Kuiper Belt. The solar system's outer border beyond Neptune lies the Kuiper Belt, a vast region filled with icy bodies, dwarf planets like Pluto, Haumea, and Makemake, and countless smaller objects. Think of it as a cosmic junkyard, but one packed with the history of our solar system. These remnants are leftovers from the early formation of the Sun and planets, frozen in time and slowly orbiting in the cold reaches of space. The Kuiper Belt isn't just a collection of frozen rocks. It's a window into the solar system's past, showing how planets formed and how material was distributed during the Sun's early years. It's also the source of many short-period comets, which occasionally travel toward the inner solar system, creating brilliant displays for observers on Earth. Even at these distant fringes, the solar system proves it's far from empty. The Kuiper Belt is full of icy worlds and ancient objects, each with its own story, waiting for future exploration. It's a reminder that the outskirts of our cosmic neighborhood are still vibrant and full of scientific opportunity. Fact 45. The Oort cloud, a frozen shell of comets. Even farther than the Kuiper belt lies the Oort cloud, a spherical shell of icy bodies surrounding the solar system. Unlike the Kuiper belt, which is relatively flat, the Oort cloud forms a vast three-dimensional boundary marking the edge of the Sun's influence. It's the birthplace of long-period comets, which occasionally travel inward and light up our skies with spectacular tails and shimmering displays. The Oort cloud itself is invisible to us, too distant and faint, but its presence explains the origin of many comets and offers insights into the solar system's earliest history. It's a frozen frontier, a distant boundary where the warmth of the sun fades and interstellar space begins. Studying the Oort cloud helps scientists understand the solar system's full scale. It reminds us that even the farthest reaches of our neighbourhood are teeming with objects shaped by billions of years of cosmic forces. The solar system stretches far beyond the planets we know, into the cold, dark depths of space, and the Oort cloud marks the first step into that vast unknown. Fact 46. Telescopes, our eyes in the sky. Before humans could travel to space, we explored it with telescopes. These incredible instruments let us see distant stars, galaxies, and planets from the safety of Earth. From Galileo's first simple telescope to modern observatories, telescopes expanded our understanding of the universe in ways imagination alone could never achieve. Telescopes collect light, allowing us to study celestial objects across the electromagnetic spectrum: visible light, infrared, X-rays, and more. This means we can observe not just what things look like, but how they behave, what they're made of, and even how old they are. They are our eyes in the sky, revealing supernovas, black holes, and star-forming regions. Telescopes don't just give us images, they give us context, showing our place in an immense dynamic universe. Fact 47. Hubble, the telescope that changed everything. Launched in 1990, the Hubble Space Telescope transformed astronomy. Orbiting above Earth's atmosphere, Hubble sees the universe with unparalleled clarity, producing breathtaking images of galaxies, nebulae, and distant stars. Hubble helped measure the universe's expansion rate, discovered new planets, and revealed the true nature of black holes. Its observations challenged assumptions and inspired both scientists and the public. Every stunning image reminded us that the cosmos is far bigger and more beautiful than we imagined. Hubble proved that space-based telescopes are game-changers. It's a reminder that sometimes stepping outside our atmosphere gives us not only a clearer view, but a new perspective on our place in the universe. Fact 48. The James Webb Space Telescope, peering into the beginning of time. The James Webb Space Telescope, launched in 2021, takes space observation even further. Unlike Hubble, it focuses on infrared light, allowing it to see through cosmic dust and observe the earliest galaxies that formed after the Big Bang. Webb's mirrors are massive, its instruments sophisticated, and its orbit far from Earth to minimize interference. It's like a time machine showing us how the first stars and galaxies emerged. Scientists hope it will answer big questions about the formation of planets, the origins of life, and the evolution of the universe. With Webb, we're not just looking at space, we're looking back in time, witnessing the dawn of everything we know. It's a thrilling leap for human curiosity. Fact 49. Exoplanets, worlds beyond our solar system. For centuries, people wondered if other worlds like Earth existed. Thanks to modern telescopes and missions like Kepler, we now know thousands of exoplanets orbit stars beyond our Sun. Some are massive gas giants, while others are rocky, Earth-like planets in their star's habitable zone. Exoplanet discoveries have changed the way we think about life in the universe. Some may have oceans, atmospheres, or conditions suitable for life as we know it. Even the sheer variety, hot Jupiters, lava worlds, and icy planets, reveals that the cosmos is far more diverse than we ever imagined. Each new exoplanet is a reminder that our solar system is just one of countless planetary systems in the galaxy, and some may even harbour life waiting to be discovered. Fact 50. The search for habitable planets. Finding a planet that could support life is one of humanity's greatest quests. Scientists search for habitable planets by looking for the right distance from their stars, presence of water, atmosphere, and chemical conditions suitable for life. Space missions, telescopes, and computer models help identify promising candidates. Even tiny hints of oxygen, methane, or water vapor in a distant planet's atmosphere can spark excitement. Potential signs of life. The search isn't just about science, it's about perspective. Discovering a habitable planet would answer one of the oldest questions humans have asked. Are we alone? And even as we explore, every discovery inspires new questions, reminding us that the universe is bigger and stranger than we can imagine. Fact 51. Life beyond Earth. Possibilities and theories. The question of whether life exists beyond Earth is one of the oldest and most fascinating mysteries humans have ever asked. Are we truly alone in the universe? Or is there life somewhere out there waiting to be discovered? For centuries, scientists, philosophers and dreamers have speculated, and today we finally have the tools to search systematically. One of the most compelling reasons to consider extraterrestrial life is probability. Our galaxy alone contains hundreds of billions of stars, many orbited by planets in the habitable zone, regions where conditions could allow liquid water to exist. With such vast numbers, it seems plausible that life might arise elsewhere, even if it is simple microorganisms rather than intelligent beings. Theories about alien life vary widely. Some suggest that life is common and will eventually be found on planets or moons with the right conditions. Others propose that life is extremely rare, making Earth a unique oasis in the cosmos. The Fermi paradox captures this tension. If life is abundant, why haven't we detected it yet? Possible explanations include the vast distances of space, our current technological limits, or the idea that intelligent civilizations might destroy themselves before becoming detectable. Researchers explore a range of possibilities, considering not just carbon-based life like ours, but also exotic chemistries adapted to extreme environments. By studying distant planets, moons, and interstellar objects, scientists hope to find hints of life, or evidence that it existed long ago. Every discovery, even a small chemical signature, could provide enormous insights into the prevalence and nature of life in the universe. The quest for life beyond Earth is deeply human. Discovering it would reshape our understanding of the cosmos and our place within it, influencing philosophy, technology, and culture. Until we find definitive proof, we continue exploring, imagining, and listening, driven by curiosity and wonder. Fact 52. The extremophiles of Earth. Clues to alien life. If we want to understand where life might exist beyond Earth, we don't have to look far, we only need to examine the extreme environments on our own planet. Microbes known as extremophiles thrive in conditions once thought uninhabitable: boiling hot springs, acidic rivers, frozen tundras, and deep-sea hydrothermal vents. Extremophiles demonstrate that life can survive extreme temperatures, high radiation, acidity, and total darkness. Their existence broadens our understanding of habitable environments and suggests that alien life might thrive in places we once assumed were barren. For example, icy moons like Europa or Enceladus may harbour subsurface oceans warmed by tidal forces, environments similar to Earth's deep-sea vents. Studying extremophiles also guides scientists in searching for biosignatures, chemical or biological indicators of life. If microbes can survive harsh conditions on Earth, researchers can look for analogous signs elsewhere, such as methane on Mars, organic compounds on Titan, or complex molecules in exoplanet atmospheres. Extremophiles remind us that life is incredibly adaptable, expanding both our imagination and our strategies for detecting it in the universe. Fact 53. Mars and the search for microbes. Mars has fascinated humans for centuries. Evidence suggests it may have once supported life, with rivers, lakes, and possibly oceans billions of years ago when its climate was warmer and wetter. Today the focus is on microbial life, the simplest forms that could survive extreme conditions. Rovers like Curiosity and Perseverance analyze rocks, soil, and atmospheric gases for signs of past or present life. Scientists look for carbon-based molecules, chemical imbalances, and mineral deposits that could indicate microbial activity. Even discovering tiny fossilized microbes would be revolutionary, proving that life arose independently beyond Earth. Mars remains a central target for astrobiology because it is the most accessible world with a realistic chance of supporting life. Each new rover, sample, and observation brings us closer to answering one of humanity's oldest questions: are we alone? Fact 54. Europa and Enceladus. Oceans beneath the ice. Some of the most promising places for life in our solar system aren't planets, they are icy moons. Europa, orbiting Jupiter, and Enceladus, orbiting Saturn, hide vast subsurface oceans beneath thick ice crusts. These oceans may be warmed by tidal forces, creating environments where life could exist, similar to Earth's deep-sea hydrothermal vents. Spacecraft like Cassini and Galileo observed water plumes erupting from these moons, hinting at chemical interactions that could sustain life. Future missions aim to sample these plumes directly, searching for microbes or chemical signatures. These hidden oceans expand our definition of habitability. Life doesn't always require sunlight. It can thrive in energy-rich environments below frozen surfaces. Fact 55. SETI, listening for cosmic signals. The search for extraterrestrial intelligence, SETI, takes a different approach. Instead of looking for life directly, it listens. Using radio telescopes, SETI scans the skies for signals from alien civilizations, seeking patterns that can't be explained naturally. Researchers focus on quiet regions of the radio spectrum, searching for narrow-band transmissions, repeating signals, or bursts of energy that might indicate intelligent origin. While no confirmed signals have yet been detected, the search continues, aided by increasingly advanced technology. SETI is more than science. It's a philosophical quest. It embodies humanity's hope that somewhere, someone else may be asking the same questions we are. Every scan of the cosmos is a reminder of the vastness, mystery, and possibility of the universe. Fact 56. The future moon bases, living on another world. Imagine waking up on the moon, looking out at Earth as a distant blue marble in the black sky. That vision may not be as far off as it seems. Space agencies and private companies are planning moon bases, where humans could live, work, and conduct science for extended periods. The moon is both promising and challenging. Its low gravity, extreme temperature swings, and lack of atmosphere make survival tricky. Engineers are exploring solutions like underground habitats, inflatable modules, and 3D printed structures using lunar soil. These bases could house astronauts for months, providing platforms for research and technology testing before humans attempt even more distant destinations. Water ice in lunar craters is key. It could provide drinking water, oxygen, and fuel, reducing the need to transport supplies from Earth. Solar power could generate energy, and advanced life support systems would recycle air and water to sustain life. A moon base isn't just science. It's a stepping stone to humanity becoming an interplanetary species. It allows us to test technologies, train astronauts, and understand how humans adapt to life beyond Earth. And of course, living on the moon would be an unforgettable experience, giving us a new perspective on our home planet. Fact 57. Colonizing Mars. The next frontier. Mars is humanity's ultimate challenge and opportunity. With its dry, dusty surface, thin atmosphere, and cold temperatures, it's not easy to imagine life there. Yet plans for colonizing Mars are underway, combining robotics, spacecraft technology, and human ingenuity. Colonization would require sustainable habitats, food production, water extraction, and life support systems. Future Martian settlers might live in pressurized domes or underground tunnels to protect against radiation and dust storms. Advances in hydroponics and in-situ resource utilization, using local materials for construction, could allow communities to thrive independently from Earth. Mars colonization is about more than survival. It's about exploration and resilience. It challenges us to think in long-term ways, balancing safety, sustainability, and ambition. And if humans succeed, Mars may become a second home, a place where the species expands beyond the cradle of Earth. Fact 58. Space mining, harvesting the cosmos. The solar system isn't just beautiful, it's full of resources. Space mining aims to extract valuable metals, water, and other materials from asteroids, the Moon, and even Mars. Water can be turned into fuel, while metals like platinum or iron could support space infrastructure. Mining in space is still experimental. Robots may survey asteroids, drill, and process materials in zero gravity. Companies are studying ways to make it economically viable, but the long-term vision is clear. Space mining could support off-Earth colonies, reduce costs for deep space missions, and even reshape the global economy. Harvesting the cosmos isn't just science fiction. It's a glimpse into a future where humanity lives among the stars and draws resources directly from them, sustainably and efficiently. Fact 59. Space tourism. Your ticket to orbit. Flying into space is no longer limited to astronauts. Space tourism is emerging, offering short trips to orbit, suborbital flights, and eventually stays on space stations or lunar habitats. Companies like SpaceX, Blue Origin, and Virgin Galactic are making the experience more accessible, though it's still expensive. Tourists experience weightlessness, incredible views of Earth, and the thrill of launch and re-entry. Beyond the adventure, space tourism raises awareness about our planet and inspires a new generation of scientists, engineers, and dreamers. One day, ordinary people might live and work in orbit, marking a major shift in humanity's relationship with space. Fact 60. Space habitats. How we might live among the stars. Long-term life in space requires space habitats, self-sustaining structures designed to support humans far from Earth. Concepts range from rotating cylinders, creating artificial gravity, to large orbital stations, and even underground colonies on other planets. These habitats must provide air, water, food, energy, and protection from radiation. Advanced recycling systems, hydroponic farms, and modular construction will be key. The goal is not just survival, but comfort, productivity, and a sense of home in an alien environment. Space habitats represent humanity's boldest experiments. They challenge our engineering, biology, and psychology, offering lessons for life on Earth and beyond. Living among the stars may one day be reality, transforming how we think about community, resources, and our place in the cosmos. Fact 61. SpaceX. Redefining rocket science. When most people think of modern space exploration, SpaceX immediately comes to mind. Founded by Elon Musk, the company's mission is ambitious: reduce space transportation costs and make life multiplanetary. SpaceX revolutionized rocket science with reusable rockets, changing a model that previously treated each launch as a one-time expense. The Falcon 9 rocket, with its first stage returning to Earth for reuse, demonstrated that spaceflight could be both reliable and economical. Crew Dragon spacecraft now transport astronauts to the International Space Station, while the Starship project aims to carry humans to the Moon, Mars, and beyond. SpaceX isn't just building rockets, it's building a vision of the future. Its approach blends rapid iteration, private funding, and bold thinking, inspiring a new era of innovation. The company has proven that private enterprise can match, and sometimes surpass, traditional government-led programs, making space more accessible than ever before. Fact 62. Blue Origin. The dream of accessible space. Founded by Jeff Bezos, Blue Origin focuses on making space accessible for everyone. The company's motto, Gradatim Ferota, means step by step ferociously. Their New Shepard vehicle provides short suborbital trips for tourists, giving passengers a few minutes of weightlessness and breathtaking views of Earth. Blue Origin's long-term goal goes beyond tourism. The company envisions orbital habitats, lunar landers, and infrastructure that allows humanity to settle and thrive in space. By gradually testing technology and investing in reusable systems, Blue Origin is laying the groundwork for sustainable exploration. Their approach emphasizes safety, reliability, and accessibility, showing that commercial companies can pursue ambitious goals while gradually building experience and technology to support life beyond Earth. Fact 63. Virgin Galactic. Space tourism. Takes off. Virgin Galactic, founded by Richard Branson, made headlines by offering civilian space flights. Their Spaceship Two vehicle carries passengers to the edge of space, providing a few minutes of weightlessness and stunning views of Earth against the backdrop of the cosmos. Virgin Galactic emphasizes experience over long missions. For many passengers, it's the first step into space, an opportunity to feel the thrill of launch, see Earth from orbit, and be part of a new era in human exploration. By opening space to private citizens, Virgin Galactic is inspiring curiosity, investment, and innovation, showing that space travel can expand beyond trained astronauts to include ordinary people seeking extraordinary experiences. Fact 64. Rocket Lab. Small rockets, big goals. Not every space company focuses on massive rockets. Rocket Lab specializes in small, cost-effective launches for satellites, opening opportunities for research, communications, and Earth observation. Their Electron rocket is nimble, efficient, and designed for frequent launches. Rocket Lab's approach demonstrates that smaller-scale missions can have a big impact. By reducing launch costs and offering flexible scheduling, the company supports scientific discovery, commercial ventures, and emerging space technologies. Small rockets may seem modest compared to SpaceX or Blue Origin, but they play a crucial role in making space more accessible and practical for research, business, and exploration. Fact 65. The rise of commercial space companies. The 21st century has seen a dramatic shift in space exploration, with commercial companies taking center stage. Private enterprises like SpaceX, Blue Origin, Virgin Galactic, and Rocket Lab are redefining how we access orbit, travel to the moon, and plan for Mars. These companies bring innovation, efficiency, and competition to a field once dominated by government agencies. They push technology faster, reduce costs, and create opportunities for tourism, research, and industry. The rise of commercial space isn't just about business, it's about humanity's future. By opening space to private enterprise, we accelerate exploration, inspire new generations, and take bold steps toward becoming a multiplanetary species. It's a new era, and the possibilities are limitless. Fact 66. Reusable rockets, the revolution in space travel. For decades, rockets were disposable, used once and discarded after launch, making spaceflight extremely expensive. That changed with reusable rockets, a breakthrough that is transforming space exploration. Companies like SpaceX and Blue Origin proved that rocket stages could return safely to Earth, be refurbished, and fly again. Reusable rockets drastically reduce costs, allowing more frequent launches and accelerating missions to orbit, the Moon, and beyond. They also enable faster experimentation. Failures no longer mean losing an entire rocket. Engineers can learn, adjust, and try again more efficiently. This revolution isn't just technical, it's cultural. Suddenly, space is no longer reserved for massive budgets or government agencies. It opens opportunities for scientific research, commercial satellites, and future human colonization. The era of single-use rockets is over. Humanity now has a chance to explore space sustainably, affordably, and repeatedly. Fact 67. Ion propulsion. Engines for deep space. Traditional rockets rely on chemical fuel for thrust, but for long-distance travel in the solar system, ion propulsion offers a revolutionary alternative. Ion engines use charged particles accelerated by electricity to create a steady, efficient push over months or years. NASA missions like Dawn used ion propulsion to reach asteroids and dwarf planets. Although ion engines produce less immediate thrust than chemical rockets, they're far more fuel efficient, making deep space missions feasible without carrying enormous amounts of propellant. Ion propulsion is a glimpse into the future of interplanetary travel. With this technology, spacecraft can journey to distant planets, moons, and even interstellar space, demonstrating that slow, steady acceleration can open paths we once thought impossible. Fact 68. Space robotics, machines that work. Where humans can't yet live everywhere in space, but robots fill the gap. From Mars rovers like Curiosity and Perseverance to robotic arms on the ISS, space robotics perform tasks that would be impossible or too dangerous for humans. These machines explore harsh environments, gather samples, repair equipment, and even assist astronauts with complex procedures. They operate autonomously or via remote control, often thousands of kilometers away. Robotics extend our reach into the cosmos, enabling discoveries and paving the way for future human explorers. Space robotics are not just tools, they are partners in exploration. They remind us that innovation often requires combining human intelligence with mechanical precision, allowing us to venture further and safer than ever before. Fact 69. Artificial intelligence in space missions. Artificial intelligence, AI, is revolutionizing how we explore space. Spacecraft use AI for navigation, analyzing data, and making decisions without constant human input. On distant planets, AI helps rovers identify interesting rocks, detect hazards, and optimize experiments. AI also powers mission planning, satellite operation, and even predictive maintenance for spacecraft. It allows missions to operate autonomously, critical when communication delays make real-time control impossible. By combining human ingenuity with AI, we expand our ability to explore the universe efficiently and safely. Artificial intelligence is no longer science fiction. It's a crucial co-pilot for humanity's journey into space. Fact 70. 3D printing in space. Building with stardust living and working in space requires ingenuity, and 3D printing offers a solution. Astronauts on the ISS can now print tools, parts, and even experimental objects on demand, reducing the need to ship every item from Earth. Future applications include printing habitats on the Moon or Mars using local materials. Imagine building a structure from lunar soil or Martian regolith. It's like turning stardust into shelter. 3D printing allows rapid prototyping, customization, and the creation of components too complex or expensive to transport from Earth. This technology represents more than convenience. It's essential for sustainable life beyond our planet. By turning local materials into functional objects, humans gain the ability to adapt, survive, and thrive in the harshest environments the cosmos has to offer. Fact 71. Radiation. The invisible danger space is beautiful, mysterious, and dangerous. One of the biggest threats to astronauts is radiation, high-energy particles from the sun, distant stars, and cosmic rays that constantly bombard space travelers. Unlike on Earth, where our atmosphere and magnetic field provide protection, space offers no natural shield. Exposure to radiation can damage cells, increase cancer risk, and harm the nervous system. For long-term missions like trips to Mars or stays on the Moon, shielding becomes critical. Spacecraft and habitats use specialized materials, water barriers, and magnetic fields in development to minimize exposure. Even on the ISS, astronauts receive doses far higher than on Earth, carefully monitored by scientists. Radiation is invisible, relentless, and unforgiving, reminding us that venturing beyond our planet is not just adventurous, it requires serious preparation and protection. Fact 72. Muscle and bone loss in microgravity. Living in microgravity is fascinating, but it comes at a cost. Astronauts in orbit experience muscle atrophy and bone loss because their bodies don't need to support weight like on Earth. Muscles shrink, bones weaken, and the risk of fractures increases. To counteract these effects, astronauts exercise for hours every day using specialized equipment like resistance machines and stationary bikes. Nutrition, vitamin supplements, and monitoring help maintain health. Understanding these changes isn't just about astronaut safety, it also informs treatments for patients on Earth with muscle or bone degeneration. Microgravity challenges the human body in ways that are invisible at first but critical to address. The physical toll of space reminds us that exploring the cosmos requires adapting our biology as well as our technology. Fact 73. Space debris. The growing threat. Above Earth, Earth's orbit is crowded. Thousands of old satellites, spent rocket stages, and fragments of debris zip around at incredible speeds, creating a space junk problem. Even tiny pieces can damage spacecraft, satellites, and the ISS. Agencies track debris carefully and plan maneuvers to avoid collisions, but the risk grows as more objects are launched. Solutions being explored include debris removal satellites, nets, lasers, and designing satellites to burn up safely in the atmosphere at the end of their mission. Space debris is a reminder that our technological reach comes with responsibility. The more we explore and utilize space, the more we must manage the orbital environment to keep it safe for current and future missions. Fact 74. The cost of reaching space. Going to space is expensive, far beyond the cost of any ordinary adventure. Rockets, spacecraft, life support systems, and training astronauts all require billions of dollars. Even with reusable rockets, space missions remain a massive financial undertaking. Costs are rising not just from hardware but also from research, safety, and mission complexity. Every gram of payload counts, every launch must be precise, and every failure is expensive. Yet the investment is worth it. Discoveries, technological advancements, and inspiration for future generations justify the cost. Understanding the price of space reminds us that exploration is both a technical and economic challenge. It's a balance of ambition, efficiency, and the human desire to reach beyond the horizon. Fact 75. Communication delays. Talking across the cosmos space is vast, and communicating across it isn't instant. Signals travel at the speed of light, which sounds fast until you realize that messages from Mars take several minutes to reach Earth. And signals from outer planets or deep space probes can take hours. This delay affects mission planning, remote operation of rovers, and real-time conversations with astronauts. Engineers design spacecraft systems and autonomous protocols to handle the lag, allowing robots and crews to make decisions without waiting for Earth's instructions. Communication delays remind us that space is enormous, isolating, and challenging. Every conversation, every command has to consider the vast distances, forcing humanity to innovate and adapt in ways unimaginable for everyday life on Earth. Fact 76. Solar exploration, probing the source of all energy. The sun is more than a bright light in the sky, it's the engine of our solar system, providing energy that drives weather, climates, and life on Earth. Yet, despite its importance, the sun holds many mysteries, from solar flares to the structure of its corona, the superheated outer atmosphere. Studying the sun isn't just curiosity, it's essential for understanding space weather. Solar storms can disrupt satellites, communications, power grids, and even endanger astronauts. Scientists use spacecraft, observatories, and probes to monitor the sun's magnetic fields, solar wind, and particle emissions. Solar exploration teaches us how stars function, how energy flows through space, and how our planet interacts with its star. By probing the sun, we not only understand our home better, but also prepare for the challenges of living and working in space. Fact 77. Parker Solar Probe, touching the sun. NASA's Parker Solar Probe, launched in 2018, is humanity's first mission to touch the sun. It travels closer to the solar surface than any spacecraft before, enduring temperatures over 1,000 degrees Celsius while protected by a revolutionary heat shield. The probe studies solar winds, magnetic fields, and energetic particles that influence the entire solar system. By getting up close, Parker helps scientists understand solar storms, coronal heating, and the forces that shape space weather. Parker Solar Probe shows that exploration isn't limited to distant planets. Sometimes the greatest challenges lie in studying the things that sustain us, like our own star. It's a daring mission, venturing into a furnace of plasma to unlock the secrets of the sun. Fact 78. The heliosphere. The bubble that protects us surrounding the solar system is the heliosphere, an enormous bubble formed by the solar wind, extending far beyond Pluto. This bubble shields us from interstellar radiation and cosmic particles, acting like a protective cocoon around our solar neighborhood. Understanding the heliosphere is crucial for space exploration. It affects how cosmic rays reach Earth, the radiation exposure astronauts face in deep space, and the interactions between solar and interstellar particles. Observations from spacecraft like Voyager 1 and 2 have given humanity its first glimpse of the heliosphere's shape and boundaries. The heliosphere reminds us that our solar system is more than planets. It's a dynamic, protective environment, essential for life and exploration. Fact 79. Interstellar space. What lies beyond our solar system? Beyond the heliosphere lies interstellar space, a vast expanse of gas, dust, cosmic rays, and magnetic fields between stars. Voyager 1 and 2 crossed into this realm, providing the first direct measurements of the interstellar medium. Studying interstellar space helps scientists understand the galaxy, the movement of stars, and the conditions between planetary systems. It also prepares humanity for future missions that might travel beyond our solar system, where sunlight fades and distances are measured in decades of travel. Interstellar space is a humbling reminder of the vastness of the cosmos. It shows us that the solar system, which feels enormous from Earth, is just a tiny oasis in the endless void between stars. Fact 80. The future of deep space navigation. Exploring the solar system and beyond requires precise navigation. Deep space missions can't rely on GPS. Instead, they use a combination of radio signals, star trackers, and onboard sensors to chart their paths. Future missions may rely on AI-driven systems, autonomous decision-making, and even pulsars, rapidly spinning neutron stars that act like natural cosmic lighthouses, to navigate accurately across billions of kilometers. Deep space navigation is more than math and technology. It's humanity's way of moving through the unknown. Every course, correction, signal and calculation ensures that spacecraft reach their destination safely, opening the door for exploration, discovery, and the possibility of life beyond Earth. Fact 81. Artemis. Humanity's return to the Moon. It's been decades since humans last walked on the Moon, but now NASA's Artemis program is bringing us back. Unlike the Apollo missions, Artemis isn't just about planting flags. It's about long-term exploration, scientific discovery, and preparing for humanity's journey to Mars. This time, the Moon isn't just a destination, it's a training ground for living and working beyond Earth. Artemis will use the Space Launch System, SLS, one of the most powerful rockets ever built, along with the Orion spacecraft to transport astronauts safely to lunar orbit and the surface. Missions plan to establish lunar bases, study resources like water ice, and conduct experiments that could teach us how to survive off Earth. These aren't just short visits, they're steps towards sustainable, long-term presence on another world. Returning to the Moon is about more than science. It's a symbol of exploration, international collaboration, and humanity's ambition to become a multiplanetary species. Each step on lunar soil gives us the experience and technology to go farther, eventually reaching Mars and beyond. Artemis is a bridge between our past achievements and the future of space travel, showing what humans can accomplish when curiosity and technology work together. Fact 82. Mars Sample Return Mission, bringing back red dust. Imagine holding a piece of Mars in your hands. That's the goal of the Mars Sample Return Mission. Rovers like Perseverance collect soil and rock samples, which future spacecraft will bring back to Earth for detailed study. This isn't just about curiosity, it's about unlocking secrets hidden on the red planet for billions of years. Analyzing Martian material in Earth labs allows scientists to search for signs of past microbial life, study geology, and understand the planet's climate history. Remote observations are helpful, but nothing compares to having actual samples in hand, examined with instruments too large or complex to send into space. This mission is a huge leap in planetary science, bridging two worlds. By bringing back Martian dust, we gain clues about the planet's potential for life, the solar system's history, and the challenges of future colonization. It's a reminder that exploration is not just about seeing distant worlds, it's about interacting with them and learning from them firsthand. Fact 83. Lunar gateways. The first spaceports. Imagine a space station floating in orbit around the Moon, acting as a launch pad, research hub, and pit stop all in one. That's the concept behind lunar gateways, orbiting platforms that will serve as waypoints for astronauts traveling to the lunar surface and eventually to Mars. These aren't just futuristic ideas. Engineers and space agencies around the world are actively planning modules, docking ports, and laboratories to make this vision real. The beauty of lunar gateways is that they allow astronauts to stay longer in lunar orbit without constantly returning to Earth. They can conduct experiments, test new technologies, and rehearse missions for Mars in a controlled environment. Think of them as spaceports in orbit, places where spacecraft can refuel, crews can rest, and research can continue uninterrupted. International collaboration is at the heart of this project. Countries like the United States, Europe, Japan, and Canada are contributing technology, modules, and expertise. It's a global effort, showing that space exploration can unite humanity in ways that few other endeavors can. Gateways are more than engineering marvels. They're symbols of a future where humans live and work in space, not just visit. By creating orbital stations around the Moon, humanity takes its first serious step toward a permanent presence beyond Earth. Lunar gateways are not just stops along the way. They're training grounds, laboratories, and springboards for exploring the entire solar system. They represent ambition, cooperation, and the idea that space isn't just a distant frontier. It's a place where we can truly belong. Fact 84. The dream of interstellar travel. For centuries, humans have gazed at the stars and imagined traveling beyond our solar system. Interstellar travel is still a dream, but it drives some of the most exciting concepts in physics and engineering. Scientists explore ideas like nuclear propulsion, antimatter engines, and light sails, trying to figure out how to cross the enormous distances to other star systems. The challenge is enormous. Our closest stellar neighbour, Proxima Centauri, is over 4 light-years away. Even the fastest spacecraft we currently have would take tens of thousands of years to get there. That's why long-term life support systems, advanced propulsion, and creative engineering are essential to make interstellar journeys even remotely feasible. Though it remains theoretical, planning for interstellar travel is more than daydreaming. It pushes technology forward, expands our understanding of physics, and inspires generations to think beyond Earth. It embodies humanity's ultimate curiosity, the desire to explore, understand, and maybe even reach other civilizations in the cosmos. Even if it takes centuries to achieve, the quest for interstellar travel fuels innovation and keeps our eyes fixed firmly on the stars. Fact 85. The search for a second Earth, one of the most exciting goals in astronomy, is finding a planet like our own. A second Earth, where life could exist. These planets, orbiting within the habitable zone of their stars, might have liquid water, atmospheres, and temperatures suitable for life as we know it. Telescopes like Kepler and James Webb have discovered thousands of exoplanets, ranging from Earth-sized rocky worlds to giant gas planets. Scientists analyze these planets' atmospheres, orbits, and conditions to determine whether they could host life. Even small clues like the presence of water or certain gases can be a huge step toward identifying a habitable world. Finding a second Earth would answer one of humanity's oldest questions. Are we alone in the universe? It would revolutionize our understanding of life, reshape our philosophy, and perhaps even pave the way for future exploration or colonization. Even the ongoing search inspires curiosity, fuels innovation, and gives hope that one day humans might live on another world, continuing the adventure of discovery that began on Earth. Fact 86. Space in popular culture. Movies, myths, and music. Space has always captured human imagination. For centuries, people have looked up at the night sky and wondered what lies beyond the stars. This curiosity inspired stories, legends, and artistic expressions that tried to make sense of the cosmos. From ancient myths about celestial events to tales explaining the movement of planets and the phases of the moon. Even without knowing what stars really were, humans used them as a canvas for storytelling, creating patterns, adventures, and lessons drawn from the sky above. In modern times, space continues to dominate movies, books, and music, becoming a central part of popular culture. Science fiction films like 2001, A Space Odyssey, Interstellar, and The Martian combine scientific ideas with imagination, allowing audiences to experience the thrill, danger, and wonder of space exploration. These films show the possibilities of interstellar travel, the challenges of surviving on distant planets, and the beauty of seeing Earth from afar. They inspire awe and curiosity in ways that textbooks alone cannot. Books have also played a huge role. Sci-fi novels from authors like Isaac Asimov, Arthur C. Clarke, and Ray Bradbury paint vivid pictures of life beyond Earth, interstellar civilizations, and technological marvels. Many scientists and engineers cite these stories as the spark that motivated them to pursue careers in space exploration. Literature not only entertains but also encourages readers to think creatively about the future, exploring what might be possible in worlds far beyond our own. Music, too, reflects humanity's fascination with space. From orchestral compositions that evoke the grandeur of the cosmos, to electronic and pop songs that capture the wonder of stargazing, music helps us feel the emotions of exploration and discovery. It turns scientific concepts into experiences that resonate emotionally, making space feel personal and relatable even for those who may never leave Earth. Popular culture does more than inspire. It shapes how we perceive space. It turns distant planets, moons, and galaxies into familiar landscapes we can imagine visiting. It teaches us to dream bigger, ask what if, and imagine solutions to problems that might arise when humans travel to other worlds. Space in movies, books, and music often blends science with creativity, showing that exploration isn't just about rockets and probes. It's about curiosity, innovation, and pushing boundaries. Through stories, films, and music, humans have created a cultural bridge to the cosmos. It reminds us that imagination often precedes discovery, and that our desire to explore, understand, and experience the unknown is as much a part of us as our scientific tools. Popular culture keeps the wonder of space alive, encouraging generations to look up, dream, and reach for the stars. making the universe feel less distant and far more attainable. Fact 87. The overview effect. How space changes perspective. Astronauts often describe a profound experience called the overview effect, the shift in awareness when seeing Earth from orbit. From space, national borders disappear, oceans and continents form a delicate, fragile sphere, and the unity of life becomes strikingly clear. Many astronauts report a deep emotional impact, realizing how small human conflicts are in the grand cosmic context. The overview effect can inspire environmental stewardship, global cooperation, and a renewed sense of responsibility toward our planet. This perspective shift isn't just poetic, it's transformative. Seeing Earth from space changes how people think, feel, and act, proving that exploration isn't only about discovery of new worlds, but also about understanding our own. Fact 88. How satellites changed daily life on Earth. Satellites orbiting Earth touch almost every aspect of modern life. Communications, weather forecasting, navigation, television, internet, and even banking rely on satellite technology. GPS allows us to navigate cities, track shipments, and manage emergency services. Weather satellites warn us of storms, hurricanes, and natural disasters, saving countless lives. Satellites also enable scientific research, from monitoring climate change to observing natural phenomena like wildfires and ocean currents. Space technology has become so integrated into our daily lives that it's easy to forget how remarkable it is. Signals travel tens of thousands of kilometers to keep the world connected. By orbiting silently above, satellites make Earth smarter, safer, and more interconnected, showing that space exploration has tangible benefits for humanity. Fact 89. The global benefits of space research. Space research doesn't just help astronauts, it benefits everyone on Earth. Technologies developed for space missions often lead to innovations in medicine, materials, energy, and environmental monitoring. Memory foam, water purification systems, and advanced imaging techniques all originated from space research. Studying Earth from space provides a unique perspective on climate, deforestation, ocean health, and atmospheric changes. These insights help policymakers, scientists, and communities make informed decisions about resource management and sustainability. Space research drives education, inspires innovation, and fosters international collaboration. It reminds us that exploring beyond our planet strengthens life on Earth in countless ways, merging curiosity with practical benefits. Fact 90. The environmental view from orbit. Looking down at Earth from space offers a clear view of our planet's fragility and beauty. Satellites and astronauts observe melting ice caps, deforestation, pollution, and urban sprawl, but they also see oceans, forests, and deserts in their pristine states. This perspective helps scientists understand environmental change and track global trends. Programs like Earth observation satellites monitor greenhouse gases, sea level rise, and climate anomalies in real time. The environmental view from orbit is a reminder that Earth is finite, delicate, and interconnected. By studying it from space, we gain insights that are impossible to gather from the ground, inspiring stewardship, conservation, and a sense of shared responsibility for our home. Fact 91. The hidden figures. The women who made spaceflight possible. Long before rockets soared into orbit, a group of remarkable women worked behind the scenes, calculating trajectories, solving equations, and making spaceflight possible. These hidden figures included mathematicians like Katherine Johnson, Mary Jackson, and Dorothy Vaughan, whose brilliance ensured astronauts could safely reach orbit and return. Their work was painstaking and precise, done long before computers could handle complex calculations. Katherine Johnson, for instance, verified the trajectories for John Glenn's historic orbit around Earth, literally putting her stamp of approval on humanity's first steps into space. These women faced discrimination and barriers, yet their contributions were indispensable. They remind us that space exploration is not just about astronauts or rockets, it's about the countless brilliant minds supporting missions from behind the scenes. Without them, the history of spaceflight would look very different. Fact 92. The engineers behind the scenes. For every launch, a team of engineers works tirelessly to design, test, and monitor spacecraft, rockets, and systems. They ensure every bolt, circuit, and software program functions perfectly, because in space, mistakes can be catastrophic. From propulsion specialists to avionics experts, engineers solve problems that no one has encountered before. They simulate launches, model trajectories, and troubleshoot unexpected issues, often working long hours to meet deadlines and safety standards. These unsung heroes are the backbone of exploration. While astronauts may capture headlines, engineers make the impossible possible, turning dreams of spaceflight into reality. Every mission's success depends on their skill, creativity, and dedication. Fact 93. Space medicine. The scientists protecting astronauts. Space is beautiful, but unforgiving. Space medicine is a field dedicated to keeping astronauts healthy in extreme conditions. Microgravity, radiation, isolation, and confined spaces. Doctors, physiologists, and researchers monitor physical and psychological health, developing countermeasures for muscle and bone loss, radiation exposure, and sleep disruption. They design exercise regimens, dietary plans, and medical protocols to ensure astronauts can perform critical tasks safely. Space medicine also informs Earth-based medicine, helping treat osteoporosis, cardiovascular issues, and stress-related conditions. Without these scientists, humans couldn't safely live and work in orbit. Their work shows that exploring space is as much about caring for people as it is about technology or engineering. Fact 94. The ground control teams, heroes on Earth. Every astronaut in orbit is supported by a vast ground control team. These engineers, technicians, and mission controllers monitor spacecraft systems, coordinate maneuvers, and respond to emergencies in real time. Ground control is where split-second decisions are made, where problems are solved thousands of kilometers away, and where lives are literally in the hands of experts on Earth. Communication flows constantly, guiding spacecraft, satellites, and human crews safely through space. Though invisible to the public, these teams are the silent heroes of every mission. Their vigilance, expertise, and teamwork ensure that every launch, orbit, and return is a success. Spaceflight is a partnership between those in orbit and those on the ground. Fact 95. The astronauts who never flew. Not every astronaut reaches space, but that doesn't diminish their contributions. Many trained for years, learning complex systems, survival skills, and scientific procedures, only to face cancellations, medical issues, or mission changes. These astronauts supported missions from the sidelines, assisting with planning, testing, and training. Their preparation ensured that colleagues in space could perform their duties safely and successfully. Their stories remind us that space exploration is about teamwork, persistence, and dedication. Success isn't measured solely by reaching orbit. It's also found in the countless hours of effort, courage, and expertise that make human spaceflight possible. Fact 96. The Lost Cosmonauts. Fact or fiction? For decades, rumors have swirled about lost cosmonauts, Soviet astronauts who supposedly died in secret space missions before Yuri Gagarin's historic flight. Some claim the Soviet government covered up failed missions, leaving these pioneers forgotten. Evidence is scarce and controversial. Some recordings, signals, and anecdotal reports suggest early attempts at human spaceflight ended tragically. But historians and experts caution against taking these stories at face value. Most official records show that Gagarin was indeed the first human to orbit Earth safely. The idea of lost cosmonauts captures our imagination because space is inherently dangerous. It reminds us that exploration carries risks, and behind every success story, there were countless trials, failures, and lessons learned, even if no one remembers the names. Fact 97. UFOs and space exploration, separating myth from reality. Space exploration naturally raises questions about unidentified flying objects. People have reported strange lights, movements, and phenomena in the sky, fueling speculation about alien life. While most UFO sightings have mundane explanations, weather balloons, satellites, atmospheric phenomena, some remain unexplained. Governments and scientists study these events rigorously. The key is separating credible observations from myths or misinterpretations. Space exploration itself increases our understanding of the cosmos, helping us discern what is scientifically possible and what belongs in stories and imagination. UFOs inspire curiosity, but they also remind us to think critically. While the universe may hold surprises, the search for knowledge relies on evidence, technology, and exploration rather than speculation alone. Fact 98. The Great Space Disasters. Lessons from Tragedy. Spaceflight is thrilling, but history has shown it is dangerous and unforgiving. Disasters like the Apollo 1 fire, Challenger, and Columbia tragedies claimed lives and left deep scars on the space community. Each catastrophe forced engineers, scientists, and agencies to rethink safety protocols, materials, and mission planning. These tragedies teach humility. Space is not forgiving of mistakes, and every design, decision, and launch procedure must be rigorously tested. They also honor the courage of astronauts and crews who risked everything to push humanity beyond Earth. Space disasters remind us that exploration comes with risk, and that learning from failure is essential to progress. Every success in orbit is built upon lessons learned from tragedy. Fact 99. The Golden Record. Earth's message to the universe. On the Voyager spacecraft, humanity sent a message to the cosmos, the Golden Record. This phonograph record contains sounds, music, images, and greetings from Earth, intended for any extraterrestrial intelligence that might encounter it. From Beethoven to whale songs, from greetings in dozens of languages to images of life on Earth, the Golden Record is a time capsule of our culture and diversity. It represents curiosity, hope, and the desire to connect beyond our planet. The record is more than a message. It's a symbol of exploration's human side. It shows that space travel is not just about technology. It's about sending a piece of ourselves into the universe, a reminder that wherever we go, we carry the story of Earth with us. Fact 100. The future awaits. Humanity's destiny among the stars. After centuries of dreaming, decades of exploration, and countless innovations, humanity stands at the threshold of a new era among the stars. Moon bases, Mars colonization, interstellar travel, and private space ventures are no longer science fiction. They're emerging realities. The future of space exploration promises collaboration, discovery, and challenges that will push the limits of technology, biology, and imagination. As we reach farther, we learn more about ourselves, our planet, and the universe. Space exploration is a story without an end. Each mission builds on the last. Each discovery inspires the next. Humanity's destiny among the stars is not guaranteed. It must be earned through curiosity, courage, and cooperation. But one thing is certain: the adventure has only just begun.